Welcome to Lesson 2. Write a polynomial from its roots. Our objectives today are to write factors given some zeros, and then to multiply these factors or binomials in order to write the polynomial in standard form, and then we want to graph to verify that we have done it correctly. Previously, we worked on finding zeros given a polynomial. Actually going backwards, we have the zeros and we want to write the polynomial. Let's look at some examples. In our first problem, we want to write a polynomial given these roots, -2, 2, and 3. So we have 3 roots, which means this is going to be a cubic function. And if we write it, let's go ahead and write out our roots. So each root, remember, came from taking a binomial, setting it equal to 0, and solving for x. In order to put this back into a factor, we just need to take the opposite sign. The first one would then be x plus 2. And you can check yourself by taking x plus 2, setting it equal to 0, and seeing if you get -2. And you should. Our second 0 or root is a +2. So that would make a factor of x minus 2. And then our third one is a +3. That would make a factor of x minus 3. So here is a polynomial. We have 3 x's. It's a cubic. Now we want to write this in standard form. This is just a factored polynomial. So in order to write it in standard form, we need to use our skills multiplying polynomials together. Well, we can only multiply 2 at a time, so I usually just multiply the first 2 together, and then I take that result and multiply it by the last binomial. Let's go ahead and do that. In our first situation, we have x plus 2 times x minus 2. In order to do that, we need to take each term from the first binomial and multiply it by each term on the second binomial. So first I will do x times x, and then x times -2. All right, x times x will give me x squared. X times -2 is -2x. Now I need to go with the 2 here and multiply the 2 by each term in this second binomial. So 2 times x is positive 2x, and 2 times -2 is -4. Okay, I have combined my first 2 binomials, but before I multiply by my third one, I would want to simplify all like terms. And here I have a -2 and a +2. Those will cancel each other out, and I'm left with x squared minus 4 times x minus 3. Now, some of you may be thinking, hey, that looks familiar. X squared minus 4, that's a perfect square, each of these. So what I have is a difference of squares, which means this can factor into x minus 2, x plus 2, which is what we had. If you can recognize this, if you have 2 binomials that are the same, one positive, one negative, you don't have to go through this long factoring process. You know that we would just square the first term, put in a minus, and square the last term in order to get to our original difference of squares. Okay, moving along though, we have one more multiplication to perform. So we need to multiply x squared minus 4 times x minus 3. And we would do that exactly the same way. We would take our first term and multiply it by each term in our second binomial. X squared times x will give us x cubed. X squared times -3 is a -3x squared. And now we move on to the 4. So we multiply that by each term. -4 times x is -4x. And -4 times -3 is +12. So here is our function after we distributed. This is our polynomial written in standard form. It's a cubic because it's to the 3rd power. So let's go ahead and graph this. And here we go. So what we need to do is type in here x cubed And it's minus 3x squared minus 3x squared minus 4x plus 12. Minus 4x plus 12. So now we can see our cubic function here, and you can tell it's a cubic because our ends go in different directions. Remember, if we stretch out our ends, it looks almost like a line. This is a positive function. It has two turning points, and we can actually zoom out if we want to see that more clearly. The turning point up here, which is our max, and a turning point down here, which is our minimum. And our end behavior, like I said, this one is going up towards positive infinity as we move to the right towards positive infinity for x, and this end is going down towards negative infinity as we go out towards negative infinity for x. And these are our zeros. We had a negative 2, we had a positive 2, and we had a positive 3. So we know that we distributed correctly and we wrote a good polynomial function in standard form. All right, let's try another example. So again, given these roots, now we have some different roots, we can write a polynomial function. So starting off, we would write our factors. And remember, it's always going to be opposite. So we have here, we have x plus 1, and we have another x plus 1. We have two of the same. Then we have x minus 3, and we have x minus 4. So now we have 4 factors, which means this is a quartic to the 4th power. So if you can picture that, what these look like, they either look like this, if it's negative, or if it's positive, it's going to look something like that, where the end behavior, both ends go in the same direction. So it's going to be one of those. Well, let's go ahead and distribute and multiply. So let's do our first two here. I'm going to do x times x and x times 1. So I'm going to get x squared plus x, then 1 times x and 1 times 1. So another plus x, and then plus 1. And then I've still got these two factors on the end. Okay, if we combine like terms, we've got 1x plus 1x, which leaves us with x squared plus 2x plus 1. And then we've got these factors. Okay, now we have a trinomial multiplied by a binomial. So I'm going to take each one of these terms and multiply it by each one of these terms. So I'm going to do x squared times x, and you can again draw a line if it helps you. So we're going to do x squared times x. We're going to do x squared times negative 3. So x squared times x will give us x cubed, and x squared times negative 3 is negative 3x squared. Now I'm going to move on to the 2x. So I'm going to do 2x times x, and then 2x times negative 3. So I'm going to get plus 2x squared minus 6x. And then finally we have a 1. Well, anything times 1 is itself, so then this is going to be 1 times x is plus x, and 1 times negative 3 is minus 3. Okay, almost there. Let's go ahead and combine our like terms. So we have this term and this term, and then we have this x term and this x term. So if we combine those, we get x cubed, the negative 3 plus 2 is minus 1x squared, or just x squared. And then a minus 6 plus a 1 is a minus 5x, and then a minus 3. So we have done quite a bit so far. We have multiplied 3 of our binomials, and we just have 1 remaining, this x minus 4. So we're going to do it exactly the same as we did the last time. We're going to take each one of these terms and multiply it by each one of these terms, called distribution. All right, let's go then. So we have x cubed times x, which gives us x to the 4th. X cubed times negative 4 is negative 4x cubed. Moving on to a minus x squared. A minus x squared times x is a minus x to the 3rd. Minus x squared times negative 4 is positive 4x squared. Now we have negative 5x times x, which is negative 5x squared, and then negative 5x times negative 4 is a positive 20x, and our final number, negative 3 times x, is negative 3x, and negative 3 times negative 4 is positive 12. So it's really just simple multiplication the entire time, and then combining our like terms when we're done. So going to underline, we've got some like terms there. And let's see, we've got some squared terms here. Got to combine those, and then we've got an x term and an x term. So we have a few terms to combine before it's all said and done. All right, so our final polynomial is x to the 4th. Combining these would give us negative 5x cubed. Combining these are going to give us negative x squared. And then combining these, 20 minus 3 is positive 17x, and then a plus 12 on the end. So first things first, let's make sure this makes sense. We have 4 roots, and I'm looking here, I do have a quartic, so at least I have the right degree. Now what I'm going to do is go ahead and plug this in to our graph and make sure that the roots that come up are the roots that I started with. Okay, so I typed in my polynomial here, and here's my graph. Now notice that if you count, and we've talked about this earlier, we only have 1, 2, 3 zeros. But remember that the negative 1, when we go back to our equation, happened twice. We have 2 negative 1s, we have a 3, and we have a 4. So really, the negative 1 right here, we have the 3, and we have the 4. That's all correct. But one thing I want you to notice is that anytime we have a binomial that is to an even multiplicity, it's called an even power, it just touches the graph and comes off. Remember that from a previous lesson. Whereas if we have an odd number for the root, it will pass through the x-axis, through that root. So we only have one of these, that's an odd number, 1, we pass through. We have one of these, so it just passes through. We had 2 of these, that's an even number, so it just hits the graph and then turns around and goes back up. And that's called an even multiplicity versus the 2 odd multiplicities. And that's really important for helping you to understand how to graph. All right, our final problem today is actually a graph this time. So we want to write a polynomial given this graph. And I just want you to feel comfortable looking at a graph and being able to pull off the zeros from a graph. So if we look at this right here, it looks like we have a 0 of negative 4. We have a 0 right here of a negative 1, and then we have a 0 right here of 3. Now let's look at this for a second. I've only listed 3 zeros. But if you'll notice the shape of this graph, my 2 ends go in the same direction, and I have 1, 2, 3 turning points. So this should be a quartic. Remember, the number of turning points is always 1 less than the degree. And since both my ends are going in the same direction, we know it's even. It has to be a quartic. But why do I only have 3 zeros? Remember what you just learned in the last example. We have 1 0 that just touches the graph and then turns around. So this 0 happens twice. So what we really have is a negative 4, we have a negative 1, and then another negative 1, and then a positive 3. Those are our zeros. I'm not going to go ahead and factor all these out again for you, or distribute, I should say, but if we were to write this problem, we would have x plus 4, we would have x plus 1 twice, and then we would finally have x minus 3. And we would go ahead and distribute all this like we did before. I just thought it was important for you guys, though, to visually see what happens when the graph touches the x-axis and turns the other way. Remember, that's an even multiplicity, which means we have 2 of that factor. All right, and that concludes our lesson on writing polynomials from its roots. So really, what's important in this is for you to practice multiplying polynomials to write a polynomial by first writing the factors from the zeros, and then to verify that your distribution was correct by graphing your final polynomial.